Hi everyone, it's Miss Costa here, and in this video we're going to go through the June 2018 Foundation Paper 1. So to begin with, we've got this question which is asking us to round to the nearest thousand. So whenever we're rounding, we just want to think, what place value are we rounding to? It's the nearest thousand, and the thousands column is where the 6 is. So essentially, one of the ways I can do this is I'm thinking, is 6,324 closer to 6,000 or 7,000? Which are the thousands that are surrounding it? I know that halfway between 6,000 and 7,000 is 6,500, and 300 is less than 500, therefore it must round down to 6,000. The other way that I can do it is just by looking, so this is, I'm rounding to the nearest thousand. I look at the place value of the digit next to it. It's less than 4, so I know I'm going to round down. Next we've got, we're ordering these integers. Integers are just whole numbers in order of size, starting with the smallest number. So whenever we do this, it's helpful to maybe just sketch a quick little number line to help you out. The further down the number line we go, the smaller the number. So the smallest of these numbers would be -6. It's also helpful to maybe think of it in terms of temperature. The colder it is, the larger the negative number is. So -6 would be my first one, then -5, then I go past 0, and then it would be 6 and 12. Next, I'm ordering decimals, so this is a little bit trickier, and it's really helpful to line them up so we can compare their place value. So I've got 0.078, I've got 0.78, I've got 0.87, and then 0.708. Now, just so that I can compare them, and with ordering decimals like this, it's kind of helpful to just fill in zeros for any of the place value where there isn't anything there. And then the cheat way is to then, once all of your decimal places are lined up, look at it and think of it in terms of that would be 870 and so forth. Or what we do is we look over here at the first decimal place. That is the 10ths column, and that has the biggest place value. So I need to start with the smallest number. So I know that the smallest place value would be the one with a 0. So 0.078 is the smallest number. Then I look in this, look to see what the next smallest number is. So I've got 7 here and 7 here. They're both equal, so I'm going to look in the next column, which is the 100th column. And 0 is smaller than 8, so I know that this is going to be my next decimal. And then once again, I know that 7 is smaller than 8, so this must be the next one, and this must be the final one. Now, you might have noticed that you could have just said, okay, well, 870, that's 78, that's 780, and that's 708. And you could have ordered it that way, but either of those ways works. The quickest thing to do is to just add in the zeros. Next, we've got percentage to a fraction, and this is a non-calculator paper, so there's different ways we can do it if we did have a calculator, but it's helpful to just know, what does percentage mean? So percent literally means out of 100. So whenever you see a percentage, you can just write it over 100. So 20% means 20 over 100. And we don't need to do anything more because it hasn't asked us to simplify. So literally, to turn a percent into a fraction, you just write it over 100. It just means out of 100. So if you wanted to, you could simplify that to 2/10 by dividing by 10, and then to 1/5, but this isn't necessary because they haven't asked you to. They've just asked to write it as a fraction, and 20 over 100 is a fraction. Next, we have a list of 4 fractions, and we're told that one of them is not equivalent to a quarter, and to write down this fraction. So you might be able to look at them and just automatically know that one of them in particular is not going to be divisible by 4, but it's helpful to just do them all. So I'm going to see if I can simplify this to a quarter. Now, when I'm simplifying fractions or finding equivalent fractions, all I'm doing is I'm dividing both the numerator, the top of the fraction, and the denominator by the same number. So 4 and 16, the largest number I can think of that fits into both of them is 4. So if I divide 4 by 4, I end up with 1. And if I divide 16 by 4, I end up with 4. So I know that this is equivalent to a quarter. I then try the next one. We've got 2/8, and I can divide by 2. And if I divide by 2, 2 divided by 2 is 1, 8 divided by 2 is 4. So that is also equivalent to a quarter. Next, just purely because this is a non-calculator paper, I would choose this one to do because it's the smallest one. But obviously if you did 15/60, that's fine. You just have a little bit more work. So 3/9. What is the highest common factor of 3 and 9? The largest number that multiplies into it. Well, the largest thing that multiplies into 3 and 9 is 3. So that's the only thing I can simplify it by. So 3 divided by 3 is 1, and 9 divided by 3 is 3. So that does not simplify to a quarter. It simplifies to a third. So I would circle this one. If you wanted to be double sure, you could also do it with 15/60. So 15, let's divide it by 5. 15 divided by 5 is 3. And then 60 divided by 5 is 12. Then simplify it again, divide by 3, and you end up with a quarter. So you know that 15/60 is also equivalent. So the one that is not equivalent to a quarter is 3/9. So that's what my final answer would be. And the way to work out equivalent fractions is just by simplifying them or multiplying them. In this case, we want to simplify. Next, we are told to write down the first even multiple of 7. So a multiple is just the numbers times tables. So people always get multiples and factors confused, but multiples are the numbers times tables. So what I could do is just start by writing the multiples of 7. Literally the 7 times tables would be 7, 14, 21, 28, and so forth. And they want the first even multiple. 7 is an odd number, 14 is even, therefore 14 is the first even multiple of 7. Then I'm asked to simplify algebraic expressions, and when we're doing this, it's helpful to just actually take it back to its base level of algebra, what's happening. So 3 times 4t, what does that actually mean? When a number and a letter are next to each other in algebra, it means they're being multiplied. So 4t actually means 4 times t. So now everything is being multiplied, and I can multiply the numbers together. So that becomes 12 times t. And when a number and a letter are next to each other, that implies they're being multiplied. So to simplify that, I would write it as 12t. Then I'm asked to simplify, and this is with addition and subtraction. So when I'm simplifying with addition and subtraction, I can only collect the like terms, which means I can only bring the terms that are the same letter together. And you can think of them as actual objects. So for instance, only with adding and subtracting, that's when it's helpful to think of it as an object. So A for apple. So you've got 8 apples and you take away 3 apples. What are you left with? Just for this part, you're left with 5 apples. So that then means you've got 5 apples and you add 2 apples. What does that become? 7 apples. So whenever you're adding or subtracting, it can be helpful to think of it as an actual tangible object, like a real life object. But yeah, that's what we do that. And to just help yourself, you can just ignore the algebra bit and just think about it in terms of numbers. So what would 8 take away 3 plus 2 give you? 8 take away 3 is 5 plus 2 is 7. Okay, now we've got the probability scale. So the probability scale is always from 0 to 100, and 0 is the probability of something, it's impossible, it never could happen. And 100, or 1 in this case, it means it's absolutely certain, there's no way, it can't not happen. So people often say, what's the probability the sun will rise tomorrow is 1, because in all of human history, the sun has risen. Okay, so it shows the probability of each of the events, A, B, C, and D. Write down the letter of the event that is certain. So over here, this is where it would be certain, so that would be D. And over here, this is my scale, so that would be from 0, which is impossible, to D, which is to 1, which is certain. And write down the letter of the event that is unlikely. So halfway through my probability scale is where the chances of something happening are even, 50-50. So therefore, in between impossible and in between a 50-50 chance is unlikely. So that would be B. Anywhere kind of like in this region is unlikely. Further this way is very unlikely. Further this way is slightly unlikely. Okay, now we are told that there are 12 counters in a bag. 3 of the counters are red, 1 of the counters is blue, 2 of the counters are yellow, and the rest of the counters are green. So I know that there are 12 in total. I know that there are 3 red, 1 blue, 2 yellow, and therefore I can figure out how many green there must be. So if there are 12 in total, I've got 3 plus 1 is 4, plus 2 is 6. So I know that this makes up 6 counters. And if there are 12 counters in total, there must be 6 green counters. So Caitlin takes at random a counter from the bag. Show that the probability that this counter is yellow or green is 2/3. So first, let's think, what's the probability of it being yellow? Well, there's 2 yellows out of a total of 12. And whenever we do probability, our denominator is the total, and then the numerator is the thing that you're dealing with in that case. So in this case, yellow, there's 2 yellows. So for green, we know there are 6 green counters out of a total of 12. So probability of yellow is 2/12. The probability of green is 6/12. And how do we work out the probability of something or something else happening when the events are mutually exclusive? So that means only one of them can happen at one given time. We use the or rule. So whenever we see the word or, trying to work out the probability of this or that happening, we add the probabilities together. So the probability of it being yellow is 2/12, and the probability of it being green is 6/12. So we just add the 2 together, which is 8/12. So that's the first part. You know the probability of yellow or green is 8/12, and we need to show that this can then simplify to 2/3. So we've got 8/12, and we can just start by dividing by 2, just to keep things simple. So 8 divided by 2 is 4, 12 divided by 2 is 6. I'm simplifying them because I'm trying to show that they can eventually simplify to 2/3, and then divide by 2 again, and divide by 2 again. So that would be 2/3. And that's how you show that. With a show that question, it's important that you show each little step of your working. Next, I've got a question about direct proportion. So 3 kilograms of meat, I'm told, costs £54. And Nina buys 2 kilograms of the meat, and I need to work out how much she must pay for that. So whenever I've got a question like this, it's helpful to just set it up as an equation. So I know that 3 kilograms is £54. I can then use the unitary method just to figure out what one lot of whatever it is costs. So in this case, 1 kilogram. How do I do that? Well, I think to myself, what do I need to divide by to get from 3 to 1? I'm dividing by 3. So I need to do the same to the other side. So I need to do 54 divided by 3. And this is a non-calculator paper, so I can use the bus stop method. So how many 3s go into 5? That's once. And how many 3s go remainder 2? And then how many 3s go into 24? That's 18. So 1 kilogram is £18. And if I know what 1 kilogram is, I can then use that to figure out what 2 kilograms must be. So what do I do to get from 1 to 2? I'm multiplying because it's 2 kilograms is 2 lots of 1 kilogram. So I have to do the same to the other side. And I end up with 36 pounds. Okay, now I have to just name some circle parts. So I'm told that the centre of the circle is marked with a cross, and I need to write down the mathematical name of the straight line shown in the circle. So a few, my brain stopped working, a few terminologies you need to know. So the name of the line from the centre of the circle to the outside is called the radius. So anytime, and the radius could be there, or it could have been here, anywhere from the center to the outside, that is the radius. So that's just the name of this one here. And then the name of a line that, a straight line on the outside of a circle that only touches the circle once is called the tangent. So a helpful way to remember it is if you know people that are supposed to be telling you a story about something and they touch on the subject once and then they go off into a completely different subject and never come back to talk about that subject again. In English, we say they're going off on a tangent. So that might be a helpful way to remember that the line on the outside of the circle touches the circle only once is called the tangent. Okay, now I've got a numeracy problem. So Tim and 3 friends go on holiday together for a week. The 4 friends will share the costs of the holiday equally. So that means whatever the cost is, they're going to split it equally. And there's 4 of them. So that means we're going to be dividing by 4. I'm told the costs of the holiday over here. And I need to work out how much Tim has to pay for his share of the costs. So I'm going to need to be dividing each of these things by 4. So I can use the bus stop method. So for the villa, I'm going to need to do 1,280 divided by 4. And some people get confused with the bus stop method, but the way you do it is inside the bus stop, you put the number that comes first. And outside the bus stop, outside the little bus, you put the number that is being divided. So we're saying 1,280 is split into 4 parts. I want to know how many lots of 4 fit into 1,280. So 4s into 1 goes none, 4s into 12 go 3 times, 4s into 3 are twice, and 4s into 0 go 0. So he needs to pay for the plane tickets. His share is £320. Then I know he pays £640 for the villa, and that's split between 4 of them. So 4s into 6 go once, remainder 2. 4s into 24 go 8, 6. It's been a long day. 6. And 4s into 0 go 0. So for the villa, it's £160. And then finally, we've got the car hire. So that's 220 divided by 4. 4s into 2 go 0, 4s into 22 go 5, remainder 2, and 4s into 20 go 4. So for the car, the cost is £54. Now we have to add all of these together. So you can add it bit by bit, or you can add it all in one go. Generally, it's safer to just add 2 things. So let's add these 2 together. So 320 plus 160 is going to give me 480. So I know that, and that is 480. And then 480 plus 54 gives me 4, 8, 9, 10, 11, 12, 13. And 4 plus 1 is 5. So in total, Tim has to pay £534 for his share of the costs. Okay, now I've got to do a little bit of reasoning, which some people find the hardest part of the exam. So I need to write down an example to show that each of the following 2 statements is not correct. So whenever they're asking me for an example, I just need to find some numbers that make the statement either true or not true. So the factors of an even number are always even. So factors are the numbers that multiply to make that number. So for instance, the factors of 2 would be 2 times 1. And that's, for example, something that proves that it's not correct, because the factors of an even number are always even. If you just say 2 times 1 equals 2, they're the only factors of 2. 1 is odd, 2 is even. So this is an example. You're not having to explain anything. You just have to find an example that proves the statement is not correct. You could have chosen any, let's do another one you could have done. So the factors are 12. What are they? We have 12 times 1, 6 times 2, and 3 times 4. So in this example, 1 and 3 are not even, they're odd. So that disproves it. So you just have to find any even number that has factors that aren't all even. Then for the second statement, it says all the digits in odd numbers are odd. So just pick an odd number. And I'm trying to show this is not correct, i.e. that there's even numbers in the odd number. So, oh, what's happened there? So for example, 17. Well, that's odd. That's odd. So that doesn't prove my case. So let's try another one. 27. 2 is even. 7 is odd. So this is an example to show that this statement is not correct. All you need to do is literally pick a number that proves that it's not correct. Okay, so in this question, I have got a composite bar chart, which is basically where you have your key and it tells you what each thing is. And instead of having them next to each other in bars, you place all of the things one on top of each other. So that's what a composite bar chart is. So I'm told that a shop sells desktop computers, laptops and tablets, and the composite bar chart shows information about the sales over the last 3 years. So 3 separate years, and each year you're comparing desktops, which are the solid black, laptops, which are shaded, and then tablets, which are grey. I need to write down the number of desktop computers sold in 2015. So desktop computers would be this bit here, the black, and that just comes in at 100 if I just read off the chart. And then this is quite a lumbersome question where it's going to require a little bit of working. I need to work out the total number of laptops sold in the 3 years. So the laptops are this bit here using the key. And first of all, what I want to do is think about what is happening with my scales. So I know that they're going up in hundreds, and that between each 100 there's 1, 2, 3, 4, 5 little boxes. So if I did 100 divided by 5, that gives me 20, which means that each little square is going up in 20s. It's really important to always consider your scales. So then I know that this is 100, and this would be 260. So between 100 and 260, that is the amount of laptops that are sold. So if I did 260, take away 100, that gives me 160. So in 2015, I have 160 laptops. I then do the same for 2016. So they start over here at 120, and then they end over here, which would be 340. This is a lot smaller on my screen. It'll be a lot bigger on your computer. So between 120 and 340, if I do 340, take 120, or I can do it like this. So 4 take away 2 is 2, 3 take away 1 is 2, so that would be 220. And then over here, I want to look at where it goes. So that is 102.46. So that's 160. And over here, that's 440. So I'm going to do 440, take away 160. So 0 take 0, I can't do 4 take away 6, so I'm going to borrow the 10s. 14 take away 6 is 8. 3 take away 1 is 2, so that's 280. So that's the amount of laptops sold in each of the years, and now I'm just going to have to add them together. So let's do some working out over here. You've got 160 plus 220 plus 280. Best way is to do it 2 at a time, but you can do 3 at a time. So that would be 0 plus 0 plus 0. 2 plus 8 is 10, plus 6 is 16, so I carry the 1. 2 plus 2 is 4, plus 1 is 5, 6, so that would be 660. Oops, 660. Next, another reasoning question. State the item that had the greatest increase in sales over the 3 years and give a reason for your answer. So just by looking at it visually, the one that has increased the most would be the grey, which is the tablets. Now, it's a reasoning question. It's only, I think, worth 2 marks. Well, it's 2 marks, so we're going to need a little bit of working for it. So, my laptops, to think about how much they increase, let's do it bit by bit. So you've got desktops. They started in 2015. You had 100. So it went from 100 sales to, what is this? 100, 246, to 160. So they've only increased by 60 in terms of sales. Then let's do the laptops. So we've already worked out the laptops because we know that they originally, there was 160 being sold. So 160 sales in 2015 to 280 sales in 2017. So that would be an increase of, from 160 to 200 is 40, plus 80 is 120. And then finally, the tablets. In 2015, we're going to have to work it out. So it starts at 200 and 246, 260, and it goes to 320. So that is, it started off with 60 sales in 2015. And then by 2017, it goes to 440 to 780. So 780 take away 440 gives me 340. So that's an increase of 280. So in terms of what's had the greatest increase, in 2015, the tablets had the smallest amount of sales. So in 2015, they had the smallest amount of sales. And in 2017, they had the largest. So it is, you could also have just done it by visually representing it. Just looking at it, you can see that the item that had the greatest increase in sales was your tablets. This is extra working to just prove it. And then it says, Alex says that in 2017, more tablets were sold than desktop computers. This means the shop makes more profit from the sale of tablets than from the sale of desktop computers. So profit is what's left when you do the selling price, take away any costs incurred. So let's say they might have sold a laptop for £1,000, but they bought it for £900. So that means they have a profit of £100. Okay, so profit is the bit that's left over once you take away the costs incurred. So profit depends on what they're selling it for. If they bought a tablet for £80 and they sold it for £500, they've made a huge profit. But if they bought that same tablet for £490 and sold it for £500, they've made a really small profit of £10. So profit is dependent on what they sell it for. So you essentially have to say that, is Alex correct? We don't know, because we don't know the cost, price, or the selling price of the items. So with the reasoning questions, they are really tricky because they require you to bring in real life knowledge. But profit is, you know, what's left over after all of your costs are incurred, and it's quite an important thing that you need to know for your GCSEs, but also just for real life, what is a profit. So yeah, we don't know the profit that they make on each item. They might only be making £1 profit on tablets. So even if they sell like 1 million, that would be a very small profit, versus if they were selling the desktop computers for a really large profit, like they bought it for £50 and sold it for £1,000. So it's just all completely dependent on the profit. Okay, then we've got a numeracy problem. So we're told that a piece of wire is 247 centimetres long. So it's helpful to just actually sometimes just draw it out. So you're like, okay, I've got this piece of wire and it's 240 centimetres long. I then know that Peter cuts two 45 centimetre lengths off the wire. So I'm like, okay, he's decided to chop off 45 centimetres from this end and 45 centimetres from this end. So the wire is going to get smaller. So what I need to do is actually think, okay, what is left over then after that's been chopped off? So I know I've got two lots of 45, which is 90. So I'm going to have to subtract to figure out what's left over. So 240 take away 90, 4 take away 2 you can't do. So 14 take away 9 is 5, and that would give you 150. So I know that there's 150 centimetres of wire left over. So I can then just draw that again. I've got 150 centimetres, and what's happening? I'm then told that he then cuts the rest of the wire into as many 40 centimetre lengths as possible. So I need to work out how many 40 centimetre lengths of wire Peter cuts. So there's a few ways you can do it. You could just do 150 divided by 40 and do it like that. Because you know you're trying to figure out how many lots of 40 fit into 150, or you could count up in 40s. So you know that's 40 centimetres, plus another 40 is going to be 80 centimetres, plus another 40 is going to be 120 centimetres, plus another 140 would be 160 centimetres, but that means you need an extra 10 centimetres. So we can't have that extra bit. So it means there's only going to be 3 full lengths of 40 centimetres. So he can cut 3. How else could you have done it if you just did division? We could have simplified this. So divide by 10, 15 over 4, and then 15 divided by 4. I could have used the bus stop method. So 4 is into 1, go once, 4 is into 15, go 3 times, remainder, so 4 times 3 is 12, remainder 3, 4 is into 30, go 7, remainder 2, and then so forth. So you know that 150 divided by 40 is 3.7. So full length means the full of the 40 centimetres. So therefore he can only cut 3 lots of 40 centimetre left. He'd be left with a stray bit of 30 centimetres at the end. Okay, next we're told that Gavin, Harry and Isabel each earn the same monthly salary. So salary is what you get paid. I'm told that each month Gavin saves 28% of his salary and spends the rest of his salary. So Harry spends 3/4 and saves the rest. So if he spends 3/4, that means that he saves 1/4, because fractions must always add up to 1 whole, and 3/4 plus 1/4 gives me 4/4, which is 1 whole. And then the amount of salary Isabel saves to the amount of salary she spends is 3 to 7. So what I can do to just make my life easier is turn this into fractions. So to turn a ratio into a fraction, you might want to think about it. So how much she saves versus how much she spends. 3 parts are what she saves, and 7, 1, 2, 3, 4, 5, 6, 7 are how much she spends. So how many parts are there in total? There's 10 parts. So therefore, as a fraction, she saves 3/10 of her salary and spends 7/10 of her salary. So that's just going to probably come in helpful. So with Isabel, what did we say? She saves 3/10 of her salary. We need to work out who saves the most of their salary each month. So we don't know what their salary is, but we know that they earn the same monthly salary. So we could either choose a random number like 100, 1,000, anything to make life easy for yourself, because it's going to be the same proportionally, or we can just compare them as percentages. So I know that Gavin saves 28% of his salary. I know that Harry saves 1/4 of his salary. So how could I turn 1/4 into a percentage? There's a few ways. You might know that 1/4 is equal to 0.25, but if you don't, that's fine. What you want to do is turn it into an equivalent fraction that has 100 as its denominator, because a percentage means out of 100. So what do you times 4 by to get to 100? You times it by 25. So you do the same to 1. If that's too big a step, then you could just think to yourself, okay, let's just make 4 bigger. We could times by 5, so it would be out of 20. And then you were like, okay, now I can times by 5 again to get to 100. So you could just do it step by step. But that means that Harry saves 25%. So we know it is a fraction, and we've just turned the fraction into a percentage. And then we know that Isabel saves 3/10 of her salary. So how could I turn 3/10 into a fraction out of 100? This one's a little bit simpler. I've got 3/10. I want to turn it into a fraction out of 100. So what do I times 10 by to get to 100? I multiply by 10. And 3 times 10 is 30. 30 over 100 is 30%. So I need to work out who saves the most. So what percentage is the largest? 30%. Isabel saves the greatest percentage of her salary. And that's how one way you could do it. The other way is if you'd just chosen a random number and worked it out proportionally. Okay, next I need to work out percentage of an amount. So there's the quick multiply method, which would be really helpful for a calculator paper, or if you're good at multiplying by decimals. If not, then we can do it the breakdown method. So what does 15% mean? It means 15 out of 100, but how can I break up 15% in nice, easy percentages? I know that 15% is the same as 10% plus 5. And something that you should all know is how to work out 10%. So 10% is one of the quick percentages that you should know the cheat method for. So to work out 10% of anything, you just divide the amount by 10. So I know that 15% is 160 grams. Oh no, sorry. I know that 100% is 160 grams, and because that's my amount, that's the thing that I'm trying to work out. So 10% is going to be divided by 10. So 160 divided by 10, to divide anything by 10, if your number ends in zeros, we just chop off the 0. So 10% is 16. And then if I know what 10% is, I could work out 5%, because what do I do? How do I get from 10 to 5? I divide by 2. So I need to do the same over here. 16 divided by 2 is 8. So I know that 15% is 10% plus 5%. And I've worked out that 10% is equal to 16 and 5% is equal to 8. And 16 plus 8 is 24. Therefore, 15% of 160 grams is 24. Okay, now here in this question, I am substituting into a formula, and it's a bit of a tricky one because I've got negatives. So the best thing to do when you're substituting into a formula is just ask yourself, what does the formula actually mean? What does the algebra mean? So 4x, when a letter and a number are next to each other, it means they're being multiplied. So 4x means 4 times by x, and then 3y means 3 times by y. I can just put that in brackets because that just means that I do 4 times x first, then I add 3 times y to it. So to work out p, I'm going to, wherever I see an x, I'm going to substitute the value that I've been given, which is 4. So I'm going to say 4 times by something and 3 times something. I'm told that x is 5, so I'm going to say 4 times 5. And I'm told that y is -2. So I'm going to substitute -2 where there's a y. So let's work through it. We always do what's in the brackets first. So 4 times 5 is 20. And 3 times -2 is -6. Now this is where you need to be very careful. When you're adding a negative, it's the same as subtracting. So that would become 20 take away 6, which is 14. Over here we've got expanding single brackets. So I've got 4e multiplied by e plus 2. So when I'm expanding brackets, I am multiplying the term on the outside by each term on the inside. So first I'm doing 4e times by e. And you can do some separate working on the side. What does 4e mean? It means 4 times e. So that means 4 times e times e. And any number or letter or anything that is multiplied by itself, it becomes that thing squared. Like if I write 5 times 5, I can write that as 5 squared. So e times e is going to become e squared. So 4 times e is going to become 4e squared. So that's the first part. And then I do the same thing. I multiply 4e by 2. So I can do my working out over here. I'm doing 4e times by 2. So 4 times e times 2. I multiply the numbers together. 8 times e, which becomes 8e. Okay, so expand. That word, we need to know what it means, and it just means multiply out the bracket. And last one is an equation involving brackets. So if I just write that out, whenever I see something like this, there's a few ways we can do it, but it is helpful to just expand the bracket first. So you've got 3 times by m, which is 3m, and then you've got 3 times by -4, which is -12. So 3m take 12 is 21. Then I want to solve this equation. So there are lots of ways that you can do this. The balancing way is just the easiest, but if you need to, you can always think of it as a function machine. So the way we do a function machine is we think to ourselves, okay, m is going into the function machine. What's the first thing that happens to it? It's being multiplied by 3, and then you're subtracting 12, and what comes out is 21. And the reason a function machine is helpful is because if you do the reverse, you can solve it quite easily. So if we're going in the reverse direction, we have to do the inverse of each operation. So the opposite of -12 is +12. And then the inverse of timesing by 3 is dividing by 3. So 21 plus 12 is going to give me 33. And 33 divided by 3 is going to give me 11. so m is 11. And that's how you do it with a function machine. If you want to do the balancing method, the function machine basically tells you the order in which you do things. So we'd add 12 to both sides, like the function machine did. So you'd be left with 3m equals 33. And then we divide both sides by 3. So m is 11. It's just two different ways to get to the same thing. Okay, now I'm told there are some chocolates in a box. A quarter of the chocolates contain nuts. The rest of the chocolates do not contain nuts. So if a quarter contain nuts, 3/4 must not contain nuts. Write down the ratio of the number of chocolates that contain nuts to the number of chocolates that do not contain nuts. Okay, so I know that 1/4 contains nuts and 3/4 does not contain nuts. To write this as a ratio, it's quite simple if we understand what's going on. What does a quarter mean? It means 1 out of 4. So it means divided by this line, which also means out of. And here, this means 3 out of 4 have no nuts. So therefore, I know that I'm going to have 1, 2, 3, 4 parts. And 1 out of 4 is going to be nuts. And 3 out of 4 is going to be no nuts. So all I need to do is turn that into a number, 1 to 3. So as long as you have the same denominator, another way you could have done it is a quarter to 3/4. And then we're trying to write it in the form 1 to n, which literally just means I want this side to be 1. So if I times both by 4, I end up with 1 to 3 as well. Okay, next we've got an adding mixed numbers. So over here, when I'm adding mixed numbers, the first thing I want to do is turn my fractions into improper fractions. So to turn a fraction into an improper fraction, we multiply the number by the denominator and then add on the numerator. So 2 times 7 is 14, plus 1 is 15. So we've got 15 over 7 plus 1 times 4 is 4, plus the 1 is 5 over 4. So step 1, turn it into improper fractions. Step 2 is, in order to add or subtract any fractions, they need to have the same denominator. You cannot add them or subtract them if they do not have the same denominator. So what I want to do is find the lowest common multiple, the lowest number they both multiply into. Sometimes it happens to be just multiplying the two numbers. So 7 times 4 is 28. And that's an easy enough thing for us to work with. So I think to myself, what have I multiplied 7 by to get to 28? I've multiplied it by 4. To keep the fractions equivalent, I'm going to need to multiply the numerator by 4 as well. 15 times 4 is the same as saying 15 times 2 times 2. 15 times 2 is 30, times 2 is 60. And then I think to myself, what have I multiplied 4 by, the denominator, to get to 28? I've multiplied that by 7. So I'm going to need to multiply 5 by 7, which is 35. And now that they both have the same denominator, I can just add them. So the denominator stays the same. It's just the numerators that I'm adding. And you've got 60 plus 35, which is going to give you 95. So that's just 95 out of 28. It doesn't actually tell you to simplify it. Normally it does. So you don't actually need to do anything else here. Over here, we're doing dividing now. So again, with division, it's really helpful if you've got mixed numbers to turn them into improper fractions. So 1 times 5 is 5, plus the 1 is 6. So you've got 6/5 divided by 3/4. Now, when we're dividing fractions, we keep the first fraction as it is, we change the sign to a multiplication, and we flip the last fraction around. So we keep this as 6/5, we change this to a multiplication, and we flip the other fraction over. And then we just multiply. And when multiplying is kind of possibly the easiest part of fractions. You just multiply the numerators and you multiply the denominators. So 6 times 4 is 24 and 5 times 3 is 15. Now it tells me to give your answer as a mixed number in its simplest form. So first of all, I might want to simplify it, or I could turn it into a mixed number. It doesn't matter, but I think simplifying it is the best thing to do. So a number that goes into 24 and 15, I can divide by 3. So 24 divided by 3. If you're not great with your times tables, you could just do the bus stop method. So 3's into 24. Oh, no, you can't because you actually need to know it. 3's into 24 would be 8. So if you weren't sure, you could just write out 3, 6, 9, 12 and write them out like that. But that would give me 8 over 15 divided by 3 is 5. So now I need to turn this into a mixed number. So I say to myself, how many times does 5 multiply into 8? That's 1. And I've got 3 left over. So I'd say that's 1 3/5. Okay, next I've got a ratio question. So I'm told that in a village, the number of houses and the number of flats are in the ratio 7:4. And then the number of flats and the number of bungalows in a ratio of 8:5. So I've got 3 different things that I'm comparing. So this is like a 3-part ratio. So I can start just by writing what I know. So I've got houses to flats, and that's the ratio of 7:4. Then I've also got flats to bungalows. So flats to bungalows is 8:5. Now, the reason I've written it like this is because if you write it as a 3-part ratio, it makes your life a lot simpler, a lot easier, because you notice that both ratios have one thing in common. Both ratios have the flats in common. So if you can make your ratios equivalent, then you can compare all 3. So I want to see, okay, I've got 4 over here. What do I need to do to turn this ratio so it's equivalent to 8? Well, if I multiply 4 by 2, that gets me a ratio of 8. So I do the same over here. So 7 times 2 is 14. 4 times 2 is 8. So I then end up with 2 ratios that I can compare. So 7:4 is equivalent to 14:8. And I know that over here, I'm comparing the ratio 8:5. So because this and this are now the same number, I can compare all 3 together in 1-part ratio. So there we go. I've got a 3-part ratio. I'm told that there are 50 bungalows in the village. So 5 parts. If I actually drew this out, I've got 1, 2, 3, 4, 5 parts, and they are equal to 50 bungalows. So what I want to do is think to myself, okay, 5 parts is equal to 50 bungalows. So that means that each part must be worth 10 units. This is a little bit of a tricky question because you've got flats, bungalows and houses. So each part is equal to 10. Over here for your houses, you need to figure out how many houses there are in the village. So I know that there are 14 parts in total. And if each of them is worth 10, what I need to do is just do 14 times 10, which is 140. I could draw it out, but it will just take a little while. So that's how we do this 3-part question. It does help to actually try and visualize what you're doing. It just helps make sense of the question a little bit more. But if you've ever got a ratio question where they're saying, this is the ratio here, this is the other ratio here, and there's one thing that they have in common, this is how you'd do a question like that. Okay, next we've got a percentage profit question. So I'm told that Renee buys 5 kilograms of sweets to sell and that she pays £10 for the sweets. She puts all the sweets into bags and she puts 250 grams of sweets into each bag. She sells each bag of sweets for 65p. She sells all of her bags and I need to work out her percentage profit. So we spoke a little bit about profit earlier on. Profit is the selling price take away any costs. So like the cost to buy the item or the cost to paint it or whatever you do to it. So first of all, let's work out her costs. So I know that she buys 5 kilograms of sweets and she pays £10 for that. And then she puts all of the sweets into 250 gram bags. So I know that 5 kilograms is £10. I could then work out what 1 kilogram must be. So 5 divided by 5 gives you 1. So I'm going to do the same to this side. So 10 divided by 5 is £2. And I know, well, I might not know, but 250 grams, I could go up in my 250s. Then I've got 500 grams, 750 grams, then 1000 grams, which is 1 kilogram. So I know that 4 lots of 250 grams fit into 1 kilogram. So I divide by 4 to figure out what 250 grams must cost. And 2 or 200 pence divided by 4 is 50 pence. So I know that her costs are 50 pence per bag. And then her selling price is 65 pence per bag. So how do I work out percentage profit? So percentage profit, the formula for percentage profit is your selling price, takeaway costs over your costs times by 100. So let's do this over here. What is the selling price? It's 65 pence. The costs are 50 pence. And the costs are 50 pence again. So 65 take away 50 is 15. So I'd be left with 15 over 50 times by 100. Now I'm going to need to do a little bit of simplifying to make my life easier. So I know I've got 15 over 50 times by 100. And it depends actually like what your maths numeracy is like as to what you're going to find easier. Probably the easiest thing would be to simplify 15 over 50. So let's start by dividing by 5. So 15 divided by 5 is 3. 50 divided by 5 is 10. So that becomes 3/10 times by 100. And 3/10 times by 100, we'd just turn that into a fraction. 3 times 100 is 300. And 10 times 1 is 10. So you'd be left with 300 divided by 10. If you, to divide both numerator and denominator by 10, we just chop off the 0. So that becomes 30 over 1, which would become 30%. So her percentage profit is 30%. Okay, so I realised I accidentally missed question 18. So let's go through that one. So this is a set notation kind of question where there's just a few things that we need to know. So when you've got something like this, it's basically saying that the members or the things that can exist in set A, these little brackets, they tell you what the conditions are. So for A, to be a part of the set A, you need to be a multiple of 5 and a number that's between 14 and 26. So we can think of what are the multiples of 5. We've got 5, 10, 15, 20, 25, 30, and so forth. And which of these are between 14 and 26? Well, 15, 20, and 25. So the members of set A would be 15, 20, and 25. In order to be part of the set, you need to be a multiple of 5, and you need to be between 14 and 26. So the members of set B are the odd numbers between 14 and 26. So what are the odd numbers? We'd start with 15, then 17, 19, 21, 23, and 25. So the only possible way you could be a member of set A is if you were 15, 20, and 25. And the only possible way you could be in set B is if you were one of those numbers. So now I'm being asked to list the members of A union B. So this little sign here means the union. And if you were to have a Venn diagram to show this, it would be everything that is in set A or in set B or in both. So what you want to do is say, okay, the members of set A, you've got 15, you've got, and we'll just do it not chronologically, in ascending order. So you've got 15, then you've got 17, then you've got 19, then you've got 20, then 21, 23, and finally 25. So I only have to write 25 and 15 once because there's no point in writing them twice. I don't want to double down on myself. So 15 appears in both of them and 25 also appears in both of them. I only need to write that once. So the union essentially means what is in set A or set B or both. So essentially every single number that is in set A and set B and anything that's in both of them as well. So all of these numbers is everything that is included in set A and B. Then I'm told to describe the members of A, and this sort of thing is the intersection, which if I had a Venn diagram and I've sorted my numbers out, it's just the things that are in A and B, literally the things that appear in both A and in B. So the members that are in set A and B. So that selection is a lot smaller. So using this, I've already circled actually the ones that are in A and B, and that would be 15 and 25. And it says describe the members of A and B. So what are these? Well, set A is the multiple, so any old multiple, whereas these ones are the odd multiples of 5. That's quite a tricky one that they're asking you to describe it, and notice that. Okay, so let's get back to the rest of the questions. So estimating with speed, distance, time. So it's really important when I'm estimating, generally they want you to be rounding to one significant figure, but sometimes that increases it changes everything quite dramatically. So sometimes it might be 2 significant figures. But I'm told that a cycle race across America is 3,069 miles in length. Juan knows his average speed is 15.12 miles per hour. And for the next race, he's going to cycle for 8 hours per day. So I need to estimate, and this is the clue. If you see this word, you know you're not going to actually work it out. And this often comes in the non-calculated paper. You don't need to work it out with all of these complicated decimals. You need to estimate, which means round the numbers to something nice that's going to help you. So let's look at the length. That's miles. That is the distance. So what could I round my distance to? It's 3,069.25. I want to round it to one significant figure, so that would round to 3,000. The reason you estimate is because you want to make the number something super easy to work with. Then I'm going to look at the speed. So I'm told that his speed was 15.12 miles per hour. So I could round it to 20. That would make it a little bit more inaccurate though. So I'm going to round it to 15 miles per hour. And then for the next race across America, he's going to cycle 8 hours per day. And I need to estimate how many days Juan is going to take to complete the race. So to estimate how many days he's going to complete the race, I'm using speed, distance and time. So what's the formula for speed, distance and time? I know that speed equals distance divided by time. If you ever get stuck, just think of the national speed limit, which is 70 miles per hour. What is 70? That's the speed. What is miles? That's distance. And per means out of, so divided by, and hours is time. So if you forget the formula, you can think of it that way. So I am wanting to work out my time. So I'd rearrange this formula. So speed is distance over time. If I cover the time over, I know that time is distance divided by speed. So to figure out how much time it's taken her, or him rather, I'm going to do the distance, which is 3,000, divided by the speed, which is 15. And this is going to be a little bit tricky because it's not calculator. The first thing you could do is divide by 5. So we could simplify it by dividing by 5. Ooh. So 15 divided by 5 is 3. And 3,000, if you need to, you can use the bus stop method, divided by 5. 5 into 30 goes 6. So that would just be 600. And then 600 divided by 3. Hopefully you're able to do that. If not, use the bus stop method. So 600 divided by 3 is going to give me 200. And obviously 3 divided by 3 is 1. So I know the time it's going to take him is 200 hours. So that's the first part that I've worked out. So if I know that it's going to take him 200 hours to get there, I can then think about how many days it's going to take. So it will take him 200 hours. And I know that he can cycle 8 hours per day. So I'm going to have to do 200 divided by 8. So once again, I can simplify this. Let's start by dividing it by 2. So that's 100 divided by 4. And then divide by 2 again. So that would give me 50 divided by 2. You could divide by 2 again, but that would just take you to 25. So that would take Juan 25 days to complete the race. If you had rounded it to 20, that would be one significant figure. But in this case, that's going to really change the answer, because rounding to 20 is like adding on a quarter of the amount of miles. So it's making a huge difference to your answer. So sometimes we need to use a little bit of, not common sense, but just think, how significantly is this going to change my answer if I'm rounding it to one significant figure? Then I'm told that Juan trains for the race. The average speed he can cycle at increases. Okay, so if speed increases, generally, so whenever you have a reasoning question, just think, sorry, I just had a think about, if we did do this question and we did round it to, let's say, 20 and 10, that still would have been fine. I think the mark scheme would still allow for it. So don't worry too much if you did round it to 20 and if you did round it to 10. The whole point of estimating is you want to make your calculation as easy as possible for you. But anyway, back to this question. So if speed increases, what happens? You get there faster. So if a car's going at higher speed, then you get there faster, which means the time decreases. So it says the average speed he can cycle at increases. It's now 16.27 miles per hour. How does this affect your answer? Well, I assumed that he was going at a speed of 15 miles per hour. 16 miles per hour would mean that the time would decrease as there's a higher speed. Although it's all about your reasoning. So you could have said it doesn't affect my answer because I still would have rounded it to 15 for ease of maths. Or you could have said if I did use 16 miles per hour, I might have rounded it to 20 and then my time would have decreased significantly. So it's about thinking, what is the impact it would have in real life and how does this apply to your question in particular? So in general, the faster he cycles, So the greater the speed at which he cycles, the less time it will take to complete the race. Okay, next we've got an elevations question. So I'm told that here is a solid square-based pyramid, and I'm asked to draw an accurate front elevation of the pyramid from the direction of the arrow. So the front view, I know that I've got a base over here of 6 centimeters, so I can just start. This is generally when they give you a grid like this, it's going to be a centimeter square grid, so each little square is going to represent a centimeter. So we can do a base of 1, 2, 3, 4, 5, 6. And we know that the height of the pyramid is 4. The vertical height is 4. So if I go to the halfway point, I can go to 1, 2, 3, 4. And then I'm just going to need to join my triangle together. So you use a ruler. And that's how you do the front elevation. You're just thinking, what is it going to look like? From the front elevation essentially means if you were looking at this face, what would it look like? So think of the vertical height and then think of the base, and they're both pieces of information that you've been given. Next, and this is a slightly trickier bit, we need to work out the total surface area of the pyramid. So surface area is where you work out the area of each face individually and you add them together. So it's a solid square-based pyramid. So if we think about the net, like if we unfolded it, it would have these 4 triangles on either side. And if we folded them back up, they'd make the pyramid. So it's kind of like, is there a sweet that is in this shape? I feel like they do some Christmas sweets that are in this shape. I can't think of the name. Anyway, what we need to do is therefore work out the area of each of these shapes. So it's a square-based pyramid. If it's a square, that means that the base is going to be, I know this side is 6 centimeters. So I know that this side here is also going to be 6 centimeters because the whole point of a square is that its sides are equal. So this is going to be 36 centimeters squared. That's the easy part. The next part is I'm going to have to work out the area of these triangles. So how do you work out the area of a triangle? Well, you work out the vertical height. So area of a triangle is base times by vertical height, or perpendicular height, you might call it, divided by 2. And it's very important we think very carefully about what height we're talking about. So in this triangle, they've given me this slant height here. And if I looked at that triangle face on, that would essentially be the vertical height because it goes from the center of the triangle to the top of it. So the base of the triangle must be 6 centimeters because it's still my square-based pyramid. And then the height, the vertical height, is 5 centimeters. So for the area of the triangle, I would do 6 times by 5 divided by 2, which is 30 divided by 2, which is 15 centimeters squared. So it's a surface area, which means I need to work out the area of each part. And because it's a square-based pyramid, it means that each face is going to be equal. So I've got 4 equal triangles that are 15 centimeters squared each. So I could label it here. So that's 15, that's 15, that's 15, that's 15, and that's 36. And then I add them all together. So 15 times by 4, I could do first. So 15 plus 15 is 30. Double that is 60. So I've got 60 plus 36, which is 106 centimeters squared. So this one was quite a tricky one. But yes, surface area just means work out the area of each of the faces. So imagine you were wrapping it. what are all of the faces, what are all of the sides that you're going to have to wrap and work out the area. Or you could imagine like dipping the whole thing into chocolate or honey or something, and like the area that the chocolate and the honey are going to cover. And when I said 60 plus 36 was 106, what I actually meant to say was 96 centimeters squared. So even if you are really good at maths, mental maths is always, especially if you're doing a lot of things, it's helpful to just actually do the working out, because you can make silly mistakes like I have just demonstrated. Okay, so this is quite a tricky question, but with all tricky kinds of questions, you can pick up so many marks just by kind of showing what you already know. So whenever you get a question that you're like, what on earth is this asking me, just see if there are little bits that you can pick out that you know information about. Because I'm pretty sure that all of you know what a square is, and so you can at least get a mark for applying some of that knowledge. So over here I'm told that a pattern is made from 4 identical squares. So if they're identical, that means that they're going to be the same length, same width, same height. They're the same shape. The sides of the squares are parallel to the axes, which means they're not diagonal. We don't have to do any weird stuff with the gradient. And then I'm given a few coordinates. So point A has coordinates 6, 7. I'm told that point B has coordinate 38, 36. And that point C is on this diagram here. And I need to work out the coordinates of point C. So it's 5 marks for this question. Even if you were just like, okay, no clue what's going on, just start by actually just thinking, what do you know? So you know that every coordinate is written as the x coordinate first and then the y coordinate. So the distance along the x-axis, it goes from 6 to 38. So what's the difference between 38 and 6? If I take that away, it gives me 32. So I know that the x distance must be 32, just as a start. And I know that there are 4 lots, 1, 2, 3, 4 lots of the side of the square that make up that 32. So what I could do is 32 divided by 4, which is 8. So just by figuring out what the x distance was, and by knowing that there are 4 sides of the square, 4 lots of a square that fit into that, I can figure out what the side of the square is. So I know that each side of the square must be 8 centimeters. And it's a square, so that means its length and its height must be equal. So I know it goes 8 centimeters across and 8 centimeters up. So that's one first step that I could take. And next step I could take is look at my y coordinates. So I've got 36, take away 7 is going to give me 29. So I know that this distance here is 29. Now this isn't quite as nice a distance because I've got one full square, another full square, but then I don't know what this is in relation to this little bit here. So I've only got a full square here, a full square here, and a full square here. And this bit here, I don't know what the distance is. So I'm going to have to do something to figure that out. Okay, so can I, using that knowledge, do anything to help me work out what the coordinates of C are? So my x coordinates, I know they start at 6. So if I worked out what this coordinate here would be, it would be 12. If I then worked out what this coordinate here would be, because I did 6, oh, not 12. So 6 plus 8 is 14. So this x value here would be 14. You can just write it as your x-axis. I know that another lot of 8 is going to get me to 22. So that must mean that the x value here for the C coordinate is 22. And now all that's left for me to do is find out what the y coordinate is. So if I start this way, I know I'm going up 8, but then I don't know what this distance here is. So perhaps I might start by going the other way. So if I go down 8 and then down 8, I'm reaching the y value of where C is. So I know that I'm starting with 36. And if I take 8 from that, I'm left with 20. Why am I finding it so hard to take away 8? 28. And then if I take away another 8 from that, the y value here, so this y value would be 28. And if I take away another 8, that would give me this y value here, which would be 20. So even though this looks like a super difficult question, if we just apply our knowledge of the x-axis, the y-axis, and just a bit of division, we can figure out how to do something like this. So 22 and 20 would be how I would do that. Okay, now I'm drawing a straight line graph. So it's a little bit of a trickier one because it's not in its normal y equals mx plus c form. It's got a negative gradient. I need to draw the graph of y equals 1 minus 4x for the values of x from -3 to 3. So what I can do is just draw a table of values where I've got my x values and my y values. And I know that I'm going from -3 to 3. So I could write out -3, -2, -1, 0, 1, 2, and 3. And now what I'm doing is I'm substituting into this equation. So 1 take away 4x. What does 4x mean? It means the y value is going to be 1 take away 4 times x. So it's always most helpful to start here with the positive numbers, just makes your life easier. So I'm going to do over here 1 take away 4 times 3. So 4 times 3 is 12. 1 take away 12 is -11. Then I'm going to do 1 take away 4 times 2. So 1 take away 8 is -7. Then I'm going to do 1 take away 4 times 1. So 1 take away 4 is -3. Then I'm going to do 1 take away 4 times 0. Anything times by 0 is 0. So that's just going to give me 1. And what you would notice is if you do this, is that each time, because it's a linear equation, it's a straight line, they're going up by the same difference. So from -11 to -7, what are you doing? You're adding 4, you're adding 4, you're adding 4. So you can actually predict what's going to come next if we just continue the pattern. 1 plus 4 is 5, 5 plus 4 is 9, and 9 plus 4 is 13. We can double check this just to make sure that we haven't done something wrong. So let's try it for -3. Y would be 1 take away 4 times -3. 1, and then -4 times by -3 is +12, because a negative times by a negative is a positive. So therefore y is going to be 1 plus 12, which is 13. So if you've got your last value right, you know you've done everything else. And now we just plot this. So we can start with 3 and 11. So I go across to 3 and then down to -11. Then you've got 2 and -7. So across to 2 and down to -7. 1 and -3, 0 and 1, -1 and 5, -2 and 9, -3 and 13. And I just connect this with a ruler and it forms a straight line. If it does not form a straight line, you've done something wrong. So you might, like, for instance, if you had a point in there and your line went like that, you'd think to yourself, okay, clearly there's something wrong with that part, and you just try and rectify it. Okay, and for the last question, we are adding column vectors. So this is kind of like, we can treat it sort of like, well, we just have to treat it like vectors. Okay, so we need to work out 2a plus b as a column vector. So I'm told that a is 5, 2. What that means is it's a movement of 5 across and 2 up. So if I know that a is 5, 2, to work out 2a, it's just like algebra, which is the word I was looking for. And all I'm doing is I'm going to multiply each bit by 2, because if that's a, 2a is going to be each part multiplied by 2. So 5 times 2 is 10, 2 times 2 is 4. b is minus 1, 7. I don't need to change that. So 2a plus b is going to be 10, 4 plus vector minus 1, 7. So what do I do? When I'm adding or subtracting column vectors, you add or subtract the x movement. So I'm going to do 10 plus minus 1. So 10 plus minus 1 becomes 10 minus 1, which is 9. So that's going to be 9. And then 4 plus 7 is 11. So that's all we're doing. It is the last question, and vectors are a tricky topic, but you literally just adding and multiplying. So hopefully that makes sense. And that's the end of that exam. And there is definitely a mistake I made on one of the questions that I just am too tired to rectify. It's question 10. It should be 535 because obviously 220 divided by 4 is 55. So this should be 55 and the final answer should be 535. I'll write it in the notes, but it's been a very long day, so apologies, but thanks for watching. If there's any topics that you want to go into more detail in, let me know. But other than that, good luck with the revision.